Oh, I know, it's been a while though since I taught this lesson, like back in May. So sometimes I don't remember what my words meant. Okay, so your blank here is imaginary solution. Imaginary solution. Okay. If this problem, okay, this is kind of like the 6 plus or minus the square root of negative 72 is as if we were doing the quadratic formula like we did a few of them on the board a few minutes ago. Okay, how would we continue this problem to actually get the final answer? We know that there's a negative underneath the square root, so what do we do with that negative underneath the square root?
Take the I out.
Okay, take an I out. All right, so take an I out and see if you can simplify this, just like we did in the beginning first two problems today. And then I hear calculators, meaning you're breaking 72 apart. So I have a group of 3s, I have a group of 2s. And I have a 2 left, right? So you guys have left is a 2?
Yeah.
Over 15. Can we reduce this at all? What can we reduce it by, Tish? 3, right? I can reduce 6, 6, and 15 all by 3. Giving me a final answer of 3 plus or minus 3i square root of 2.
Should be 2.
Yep, should be 2. Thank you for paying attention. Two plus or minus 2i square root of 2 over 5. Okay, so what does this actually mean, though, when we have an imaginary solution? Why do we even use I? What's the point of using I? Why? That is a great question, okay? So what's going to happen is if we know what's happening underneath the radical, if I know what's happening underneath here, I can tell you what the graph is going to look like. If I get a negative underneath there, okay, then that means that my graph is going to be doing something a little bit different. What's the point of solving these equations? Do you guys remember what we said the point was?
Finding the x-intercepts.
Excellent. Finding the x-intercepts. You're probably going to need to know that. Why do we factor? And because I said so is not going to be a good answer.
To graph it.
There you go. To find out where the x-intercepts are on the graph. Okay? So that remember, keep that in mind that that's the whole point of what we're doing here. So when we're doing this, and we find a negative underneath the square root, that means that something special is happening. Okay, and so, as I zoom out, we are going to talk about what's called the discriminant. This word discriminant means that this is how many roots or solutions you're going to have underneath the graph. That's the whole point of finding what the discriminant is. Okay, so the discriminant is only what's underneath the square root. All right, so make yourself a note at the bottom, maybe where it says discriminant, or off to the side. The discriminant
There's no E
there's no E.
at the end.
Yep. Discriminant. I fixed it. Discriminant. This is not discriminate. Those are two different words. The discriminant, okay, tells us the number and type of solutions. What's another word for solutions? Roots. What else?
Zero.
Zeros. What else? Yes, x-intercepts. Okay, all those mean the same thing. So the discriminant comes from just what is underneath the square root sign. So if we think about our quadratic formula, the thing that's underneath the square root sign is just b squared minus 4ac. So if we find out what b squared minus 4ac is, and we get it to be a positive number, so it's greater than 0, that means it's a positive number. This means that we are going to have two real solutions. And I'm abbreviating solutions. We're going to have two real solutions. So if underneath the square root we get a positive number, we know that we're going to have two real solutions, and this is what the graph might look like. Two real solutions means it's crossing the x-axis twice. So I have two real solutions here and here maybe. All right, if I am finding the value of the discriminant, it's just a number, and I solve it out and I get the number to actually be exactly 0. So if I do b squared minus 4ac and I get 0. So if I was working the problem out and underneath the square root I got a 0. This means that I would have one real solution. Like in your homework when you factored the problem out, you just had x equals 7 and x equals 7. That's only one answer, even though it's two different numbers or two of the same number. That means that the graph is only crossing how many times? Once, which means it is sitting, it can go up or down, but it is sitting, the vertex is on the x-axis. Okay? That would be what one real solution looks like. Are there fake solutions?
Yes.
Say that again?
Imaginary solutions.
Imaginary solutions. Okay, now we've got the wheels turning. So if I get b squared minus 4ac, we already have a positive number, we have it equal to 0, what's my next option?
Less than.
A negative number, right? So if it's less than 0, that means it's a negative number. And we talked about what happens if I get a negative underneath the square root. What does that give us? How do we keep doing the problem?
1.
Not 1, an I, right? We deal with the I when we get a negative underneath the square root. This tells us that I have two imaginary, or you can say complex, solutions. Two imaginary or complex solutions. What this graph looks like is if you were to graph your parabola, it's not going to touch your x-intercept or your x-axis. That's what imaginary solutions look like. They never touch the x-axis. So your parabola will not get close to it maybe, but never touch it. All right, so determining the discriminant is going to tell you what the graph is looking like and going to tell you what kind of answers you're going to have for your graph. Okay, so down there at the bottom where it says discriminant, let's go ahead and put the formula for the discriminant right there. The formula for the discriminant is just b squared minus 4ac. There is no square root above it, just b squared minus 4ac. That's all you're doing. And that comes from the quadratic formula, right? Okay, so if we look at the next page, the next examples, it says find the discriminant. All I need to do is find the value of the discriminant. So if I have b squared minus 4ac, remember this is my discriminant expression. What do we need to remember to do first, do you think? Move the 9, okay? We need to set it equal to 0, but what do we always have to remember about the x squared term? It needs to be positive. So really, we should move the x's. Now, if you want to move the 9 over, that's fine. You're just going to have to then divide the entire equation by a -1, which is a little more work. Okay, so instead, let's add 3x squared and add x over to the other side. Put it in standard form. Okay, what's the b value here?
The A.
B value is 1 right here, right? So A is 3, B is 1. What's our C value? 9. So if I do b squared minus 4ac, nine squared minus 4 times a times c. Oh, my b is wrong. Sorry, 1 squared, right? So I have 1 minus 12 times 9 is 108. What is 1 minus 108? Negative 107. So the value of this discriminant is negative 107. What does that tell me about the graph?
It's imaginary.
It's imaginary.
Or complex.
Yeah, or complex. Either word works, whichever you choose. That's fine. Okay? That's really all there is to the discriminant, guys. So let's try number 2. What's the first thing I need to do on number 2, Tracy? Okay, so what are you going to do with that 4? Excellent. So we're going to subtract 4 over. Okay, so we're labeling our A, B, and C. I'm just going to put it into our formula. Remember, you have a negative and a negative here, so that means that this problem is going to be a positive. And then 4 times 10 is 40. What's 40 times 9? 360. So if my math serves me correct, 424? Anybody else get 424? So the value of this discriminant is 424. So Crystal, what does that mean about our solutions?
That it is two real solutions.
Perfect. 2 real solutions because the number is positive. Any questions about that? Okay, let's try number 3. We're doing the exact same thing, except now we're actually going to write out, is it 2 real, 2 imaginary, whatever. Okay? Try number 3. Are you guys getting 0?
Yes.
Okay.
Got 1.
What'd you say, Anthony?
I got 1.
You got the...
Yeah, I got 1. That's positive 1.
Do you have 36 minus 36?
No, I have 36 minus 35.
We have 4 times 9.
I got 35. Oh, yeah.
36. There you go. Okay, so if it's 0, Emily Hagee, How many solutions do I have? Perfect. Is it real or fake? Good. We don't really have fake. We just call them imaginary. So you'd write 1 real, and this is going to be your answer that's acceptable. The value of the discriminant is 0, and it has 1 real solution. Okay, try number 4. Are you guys getting negative 16?
Yes.
Okay, Patrick, what kind of solutions do we have? 2 what?
Imaginary.
Good. 2 imaginary. Or 2 complex. I don't really care which word you write. All right. On number 5 and 6, it says, after you find the discriminant, draw me a rough sketch of what that parabola should look like. So just like we did in that 3rd column of your chart, that's what you're going to do here. So you need to find the discriminant first, and then determine what the graph should look like. And we're doing just a sketch, rough sketch. That's why it says rough sketch there. So our discriminant is 76. So if it's a positive number, what kind of answers do I have, Justin?
2 real solutions.
2 real solutions, which means my graph should do what?
Cross the x-axis twice.
Cross the x-axis twice. And I know that it opens up because my a value is 1. So I'm going to just open it up. Again, really rough sketch. All right, I'm not even sure if it's going on both sides of the y-axis, but just an up that it's crossing twice. Any questions on number 5?
No.
Okay, try number 6 for me. It'll be our last example. Okay, negative 8. Kyle, what kind of graph does this look like?
I'm like not touching any of the lines.
Okay. Which quadrant?
Yeah, but since it's negative,
This is
I didn't put it on the positive quadrant. I put it on 2. But I guess it could be on 3, but it can't be on 1 or 4.
ooh.
Wait, what?
Okay. So what she's saying is this is a positive, right? This is opening up because our A is positive. But if we drew it here, it's eventually going to touch the x-axis.
Yes,
Right?
you're right.
Okay, so it can't be in this quadrant going up. And it can't be in this quadrant going up because it's eventually going to touch it. So it's going to have to be in quadrant 1 or 2 going up. Again, it's a rough sketch, so I don't really care which one you put it in. 1 or 2 works. I think it's actually probably going to be in quadrant 1, but so we've got all positive numbers. Okay, any questions about this?
No.
Pretty easy, huh?
Yes.
Sure.
Are they gonna count?